Hello everyone, I welcome you all to today's session wherein we will be discussing the simple interest, compound interest concepts, and this is the third video in the series of simple interest, compound interest. Now in the previous two videos we have seen concepts of simple interest, compound interest, simple interest versus compound interest. In today's session we shall be looking at the remaining part of the simple interest, compound interest chapter, which is the installment concept, and also briefly we will be touching upon the concept of compounding as well. So let us start with the compounding first. Okay, just a minute. So generally what do we mean by compounding is the process of calculating the interest at a certain rate of interest on the principal amount, adding to the principal to get the final amount. This entire process we call it as compounding, and generally speaking this happens once in a year, that is at the end of the year. But the compounding could happen much more than that, before that also. Maybe it could happen monthly, it could happen quarterly, it could happen every 6 months, it could happen every day for that matter. So compoundings could vary. So depending on this, there is this concept that we have of multiple compoundings. So I hope the meaning of compounding is already clear to us. So multiple compoundings. So imagine if you are compounding 3 times a year, right? 3 times a year, for example. I'll take an example for this. Let's say we borrowed 10,000 rupees and here the rate of interest was 40% and the period was 1 year. So if you compound only once, then what will happen? If you compound only once, at the end of first year, the interest will be calculated at the rate of 40% of 10,000, which is nothing but 4,000. It will be added to the principal amount and the final amount will become 14,000. Whereas, if you take the same 10,000, same rate of interest, same period, but this time you are compounding twice. You are compounding twice. So when you compound twice, the compounding will happen after every 6 months, isn't it? After 6 months first compounding, again after 12 months second compounding. So what will happen after 6 months? Let's look at it. So after 6 months what will happen is, the rate of interest, please also understand, for the entire year it was 40%. So for the 6 month period it will be half, 20%. So the interest will be 20% of 10,000, which is 2,000. So that means the total amount after 6 months will become 12,000. Now again 6 months later, that is overall 12 months later, compounding will again be done, again at the rate of 20%. Now this time it will be 20% of 12,000, which will give us 2,400. So that means overall in this 1 year, the total interest earned is 4,400. So the final amount will become 14,400. It is more than the amount that we got here, because we are increasing the compounding. So one general understanding that one can derive out of compounding is, if you compound for more number of times, the final amount or the total interest accumulated is going to be bigger. More compoundings means more interest. However, there is one small formula that we need to know about multiple compounding, which is infinite compounding case. So if you take the case of infinite compounding, the final amount is given as principal P into constant E to the power n into R by 100. So if at all in your CAT examination, if you come across a question involving infinite compounding, then this is the formula that we should remember. P is the principal, E is a constant value, 2.718 is the value, N is number of years, R is rate of interest. This will give you the final amount. So this is little bit about the concept of multiple compounding. Next, we shall take up the concept of installments, but for doing that, we will take up examples given in the slide here. Let's look at the first example. So it says Arvind borrows 1,650 at 20% rate of interest. Interest compounded annually. He plans to pay back the loan in 2 equal annual installments. What is the installment amount if installments are paid at the end of each year? So how is the overall taking of loan and paying back happening? At t equal to 0, that is today, I have taken 1,650 rupees loan at rate of interest 20%, right? And the plan is to pay it back in 2 years. So that means after the first year, I'll pay back some amount. Let's say the amount is X. After second year, I'll pay back again the same amount. He says equal annual installments. So X and X. Now you have to find the value of X if these two installments are actually clearing the loan. Now what do you mean by clearing the loan? Whatever principal I have taken, I have to pay it back. Along with that, I also have to pay back any interest that would have accumulated over these 2 years. I am sure there will be some interest also. So we have to pay back that interest too. So how we can think about this problem is, look at this. So if you look at the calculations, for the first year, what's the rate of interest? 20%. So interest for the first year, can I say is 20% of 1650, which happens to be 330 rupees. 165 into 2, 330. So this will be added to the principal amount, and thus can I say amount at the end of first year is going to be 1650 plus 330, which is 1980, out of which we are paying back X. So that means for the next year here, the principal amount will be 1980 minus X, not 1650. So that means here interest for the second year will be what? This will again be 20% of this value. Okay, so that means amount at the end of second year will be what? It is going to be the principal amount plus the interest which is accumulated. 100% of 1980 minus X plus 20% of 1980 minus X will be 120% of 1980 minus X. So that means at the end of second year, this is the total amount due that we have to pay back. But how much are we paying back? We are paying back X. So this should be equal to X. So when you solve this, 120% is nothing but 6 by 5. 6 by 5 into 1980 minus 6 by 5x goes on the other side, will become plus. It will give me 11 by 5x. By 5 will cancel out. 11 will go away 180 times here. So 6 into 180 will give us what? 1080 rupees is going to be our installment amount. So 180 into 6, I believe is 1080. That will be our installment. That's what he asked us to find out. So this installment problem can be solved by simply following the calculation process used under compound interest. We could do it like this. This is one way of looking at it, alright. You can copy this. Alternately, so remember the answer, we got 1080, right. Alternately, we could try to use few other concepts, which is the concept of present value, future value. Let me try to show it using that also. Observe. Let's say I want to use present value concept first. Listen to this point carefully. I am paying back X rupees installment after 1 year, X rupees installment after 2 years. Now let's say I want to prepay this liability. I want to prepay it now itself. I want to pay up some amount such that this X will become unnecessary. I want to pay some amount here only such that this X becomes unnecessary. What are those amounts? So basically I am asking you, what is that present value of this first installment which will help us in avoiding this payment entirely? Try to understand. Say I have taken a loan, 1 lakh rupee, alright. So every year I have to pay 10,000 rupees interest. Simple interest, let's take the case. So after 10 years, how much should I pay? It's 2 lakh rupees, right? 1 lakh rupee the principal plus 1 lakh rupee for 10 years the interest. Now let's say after 5 years itself I hit a jackpot. I get large amount of lottery win, right? Lottery win. I want to close the loan after 5 years only. So if I want to close the loan after 5 years, can I say logically speaking, I won't be paying back 2 lakhs. I would rather be paying back 1 lakh the principal plus interest for 5 years only, not 10 years. So that means in order to clear the 2 lakh rupee loan after 10 years, I can pay 1.5 lakh rupee after 5 years. So that 1.5 will be the present value of that 2 lakh due after 5 more years. From 5 years, it's 5 more years, right? That is what is present value. So what will that amount be here? I don't know what it will be. Let's say this first installment, I call it as X1 is a present value, right, for this first installment. So can I say this X1 multiplied by the rate of interest? We are using CI, so I'll use CI formula, should be equal to X. This present value multiplied by the increase after 1 year should become X. So I put it equal to x. Similarly, x2 is the present value of the second installment into 1 plus 20 by 100 whole square after 2 years should also become x. So when you solve this, 1 plus 1 by 5 is 6 by 5. So x1 will become 5 by 6 into x. Here x2 will become, when you simplify this, this is 6 by 5 the whole square, 25 by 36 x. Now listen, this is the present value of the first installment, present value of the second installment. Now can I say, since we are dealing in present, their sum should be equal to 1650, the total loan that I have taken. So x1 plus x2, which is nothing but this, should be equal to 1650. Taking LCM, 3055 by 36 x will be equal to 1650. 55 will go entirely 30 times. So x will be 30 into 36, which is 1080 rupees. We got the same answer, but this time by using a slightly different concept. Okay. Now look at the third way of looking at it. I'll go for the future value. Let us say I did not pay this first installment, it was due but I did not pay. I am paying it after 2 years. So if I am paying it after 2 years, can I say the value of the first installment will be increased by 20%. So what will be its due here? So it's going to be x into 1 plus 20 by 100, which is nothing but 6 by 5 x. Second installment was due after 2 years only, I am paying after 2 years. So it's going to be x. So can I say the total amount paid after second year to clear my loan will be 6 by 5x plus x. But this should be equal to what? This should be equal to the future value of 1650 after 2 years, correct? So after 2 years, 1 plus 20 by 100 whole square. When you simplify this, this will give you 11 by 5x. This is going to be 1650 into, this is 1 plus 1 by 5, 6 by 5, 36 by 25 it is. So 5 goes 5 times, 11 will go 150 times, again this is 30 times, you will get x as 30 into 36, 1080. Same answer. So this is the third approach of getting to the answer. Now let me also share the fourth approach. This installments problem, particularly which are based on compound interest, compounded annually, can also be solved by a simple formula. The installment value is given as principal into r by 100 by 1 minus 100 upon 100 plus r whole to the power n, where r is the rate of interest, n is the number of years, p is the principal amount. So when you use this here, let's see what do we get. Principal is how much? 1650 into rate of interest is 20 by 100 by 1 minus 100 by 100 plus 20, which is 5 by 6 whole power n, number of years is 2. So this is 1650 by 5 upon, this is 36 minus 25, 11 by 36. So again this will go, 5 will go 30 times, 11 will go 30 times, 30 into 36 is once again 1080. So we can solve our question in 4 different ways, right? I have shared 4 different approaches for you. You can decide, but please do practice this approaches more and more. We got the answer for this question, but the purpose of taking up this question was so that I could introduce these various approaches. I hope we are clear. You can copy them. Next, similarly, now look at this. A loan is taken today and repaid in 2 annual installments of 2783. The first installment is repaid at the end of the first year. If the rate of interest is 10% and it is compounded annually, find the sum borrowed. So can I say, I'll use the formula directly. Installment amount 2783 is equal to P into rate of interest is, I think, 10%, yes, by 1 minus 100 by 100 plus 10, 110 whole to the power 2. Again we are paying it back in 2 years. So when you simplify this, right hand side simplification, so it's going to be P by 10 by 1 minus 10 by 11 the whole square is going to be 121 minus 100, 21 by 121. So when you simplify, this is 2783. This is 2783. So when you simplify, 121 will come in the numerator, and this 10 and 21, 210p. This will become 210. This is 2783. I think we can cancel out by 11 on both sides. So 11 will go 11 times, 11 here goes 2 times, 58 5 times, 3 253 times. Once again 11 will go 2 times, 3 times. So hence the value of P will turn out to be 23 into 210, which is nothing but 23 zeros 0, 23 ones 23, 2 carry, 23 2s is 46 and 2 48. So 4830 was the loan that I have taken, and we can use a formula for this, or you can go for any of the other 3 approaches that we have discussed. I am not doing that for every problem, you can do it yourself. I hope we are clear. Sorry. So with that we have come to the end of the session here. So in this video we have covered the installments in great detail. I have shared 4 different ways of solving questions from installments, alright. Generally installment problems come from compound interest. If the case is of simple interest, you can apply the similar approaches for simple interest. However, remember the formula is shared for installment calculation, that is only for CI, not for SI. So on that note, let me end the session here. Thank you and all the very best.